Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 5-9 lesson on trigonometric quadratic equations. In this one, we will be considering trig equations where we have either quadratic trig terms or multiple function types in the same problem. Before upping the difficulty on trigonometric equations, however, I think it would be a good idea to review just basic algebraic equations. So pause the video and try these three out. Let's see what we came up with now. First one, we have to subtract the 3. And we can square root both sides. That'll give us x equals plus or minus 2. Don't forget the plus or minus when square rooting. Over here, number 2, we have to factor. So we can break this into x minus 2, x plus 3. 2 times 3, negative 2 times 3 is negative 6. You add them together, that's positive 1. So we get x equals positive 2 and negative 3. Over here, we have to resist the temptation to just divide everything by y. We're never allowed to divide by variables. However, we can subtract y and then factor a y out of this. So then we can say x equals 1 and y equals 0, because if you plug 0 in for y, you solve the equation. You make the whole thing 0. Now that we've gotten a little bit of a review of algebra, let's see if we can apply it to solve this quadratic trig equation. So this is kind of tricky at first glance. We've got secant squared of theta plus 3 equals 7. We've never really seen a squared trig function before. Basic idea here is you've essentially got secant of theta times itself. This is kind of like an x squared in terms of how it behaves. So our strategy on this, we're going to find a way to break our equation down into first degree trig equations. So we want to end up with a situation where we have secant of theta with no square equaling a number. And we can do this using all the algebra techniques from before, square rooting, factoring, all of them. So pause the video and see if you can break this down into first degree equations. All right, so the key on this one, since we don't have another secant floating around, we can just subtract the 3 and square root both sides. This is kind of like an x squared equals 4 situation. So we can write secant of theta equals positive 2 and secant of theta equals negative 2, because remember we have a plus or minus when we square root both sides of an equation. And at this point, now that you've got it broken down into first degree equations, we're going to solve each branch as we normally would. So if you didn't get this far, pause the video again and see if you can take it the rest of the distance on each of these branches. All right, so for this first branch, we have secant. That's no good. We want to turn that into cosine. So we'll write this as cosine equals 1/2. Just took the reciprocal of both sides there. And we see that cosine is positive. That means I'm expecting answers in quadrants 1 and 4. That's to the right of the y-axis. So now let's do inverse cosine of 1/2. You could do this on the calculator, or you might remember that the cosine of 60 degrees equals 1/2. So inverse cosine of 1/2 is 60. This is itself already a reference angle, so we're good to go on that part. And we were looking for quadrant 1. Well, we've already got quadrant 1. It's 60 degrees. Now for quadrant 4, we can do 360 minus our reference angle of 60, giving us 300 degrees. So that's just for one branch. The tricky thing on these is that you're never done after just one branch. You also have to solve the other branch for the other possible answers. So let's go ahead and solve this one now. We're going to follow pretty much the same pattern we did over here, though. This is going to become cosine equals negative 1/2. And we're going to have to, now let's figure out what quadrants we're in for this one. So since this is a negative cosine, that means we're to the left of the y-axis in quadrants 2 and 3. Now it's time for inverse cosine of negative 1/2. And you might know off the top of your head that this is 120 degrees, or you could do that on the calculator. Either way, we need a reference angle now. So we're going to have 180 minus 120, giving us 60 again. So same reference angle as over here. And we wanted quadrant 2 and 3. Well, quadrant 2, we actually already have that answer. It's 120 degrees. For quadrant 3, we want to do the 180 plus our reference angle of 60, which gives us 240 degrees. Now you might be wondering, am I always going to end up with 4 answers on these? Not necessarily, but you can have up to 4 answers if you have a second power trig equation. For this next problem, we're trying to solve this quadratic trig equation with tan in it for radians between 0 and 2 pi. So this is kind of like having x squared plus x minus 6 equals 0. Following the example of one of our warm-up problems, see if you can get this into first-degree trig equations. Pause the video, give it a shot. All right, so if these were x's, I would factor this into x minus 2 and x plus 3, two numbers that multiply to negative 6 and add up to positive 1. Well, instead of using x's, I'm going to do tan of theta minus 2 times tan of theta plus 3. And if you were actually to FOIL this out and combine like terms, we would get what we started with. So setting each of these equal to 0 now and solving, we can say if tan of theta minus 2 equals 0, then tan of theta equals positive 2. And if tan of theta plus 3 equals 0, tan of theta equals negative 3. So these are our two branches that we're now going to go ahead and solve. Feel free to pause the video and pick up at this point if you didn't get this far. All right, so for this first branch, we see that tan is positive. So that means I'm going to be in quadrants 1 and 3, where the slope of the angle is positive. I need to do inverse tan of 2 on the calculator now, and I have no idea what that is. Let me find out what it is. Now, when I'm doing this on the calculator, I'm going to do it in degrees mode. I'm just going to convert to radians at the very end. So I've got 63.4 degrees initially. That is a reference angle, which is nice. And I wanted quadrant 1. Well, I've got quadrant 1, 63.4, right off the bat. Now, for quadrant 3, I'm going to have to use this reference angle and add it to 180. So that's going to be 243.4 degrees. And again, I'm going to convert to radians at the very end. I'm just going to go through and get the rest of my answers in degrees, starting with this branch up here. So we see here that tan is negative. That means I'm in quadrants 2 and 4, where the slope of the angle is negative. So let's do inverse tan of negative 3 now on the calculator. And that value is going to be negative 71.6 degrees. Not quite a reference angle, but pretty close. The reference angle is just going to be positive version of this because we're 71.6 degrees from the x-axis. And now let me find my answers in quadrants 2 and 4. For quadrant 2, we need to do 180 minus this reference angle. Let me do that on the calculator. So that's going to end up being 108.4 degrees. And next I need quadrant 4. So that's 360 minus 71.6. Let me do that one now. And for this, I'm just going to go up and steal my input from earlier and change that 180 to a 360, kind of convenient. So that's going to be 288.4 degrees. And I'm almost done, but now I have to go through and change these 4 degrees answers into radians. Now remember to do this, we're multiplying by pi over 180 on the calculator. I'm going to do 63.4 first. Now to make my life a little bit easier, I'm actually going to create the value pi over 180. So I'm going to do alpha y equals and do a fraction with pi over 180. And I'm going to store this value, press the stow button. Actually, let me go up here. There we go. Store this as, I'm going to do alpha a, just so I can store it as the letter a. Now, whenever I write a next to something, it's going to multiply by this conversion factor. So let me go through and do all of these now. We've got 63.4 times alpha a, or times pi over 180, comes out to 1.11 radians. Very good. And next, I want to do 243.4 times alpha a, and that comes out to 4.25 radians. So if you're going to be doing this a bunch of times, this is a nice little shortcut with this stored value here. Now we've got, it looks like 108.4. That was the answer. The 71.6, that was just our reference angle, so don't get them mixed up. And now alpha a, that comes out to 1.89. And finally, 288.4 times alpha a, or pi over 180. And that's going to come out to, survey says, 5.03 radians. So there they are. We're going to do one more problem here. This is a lot like your third warm-up question. Pause the video and see if you can use the lessons learned there to unravel this one. So our first step, we want to make sure we can't just divide by tan on both sides because that would be like dividing by a variable. So we have to subtract this tan over to the left side. And then, just like that third warm-up where we factored out a y, we can factor out a tan of theta. So that would give us tan of theta parentheses sine of theta minus 1. And then just like on that problem, we can say tan of theta is 0, and then sine of theta will equal 1. Let's solve each of these branches individually now. So here, let's see, where is the slope, that's the tangent of an angle, equal to 0? Well, that happens at 0 degrees and 180 degrees. And they want the answer in degrees, they said at the beginning, so we're good here. Now over here, where is the sine of an angle, where's the y value of an angle equal to 1? Remember, with 1 and negative 1, for sine and cosine, that only happens in one place on the unit circle. This one's going to be 90 degrees. So we're done. Or are we? So here's a little trickiness on this question that we haven't really encountered up to this point. When you have two different trig functions and you're getting different answers from different trig functions, you have to be very careful, because answers you get from one trig function may make other functions in your equation undefined. So remember, there's 4 trig functions that are actually technically fractions with sine and cosine in them. Tangent, cotangent, secant, and cosecant all have the potential of being undefined when you plug in certain values, because again, they're made from ratios. So anything you get from tangent itself is going to be okay as far as tangent is concerned. It wouldn't be able to return something that made its own self undefined. However, this 90 degrees that you got from the sine branch, 90, well, that is at the top of the unit circle, and at the top of the unit circle you have an undefined slope, an undefined tangent. So because tangent is undefined at 90 degrees, you actually have to throw out this answer of 90 degrees. It's an extraneous root. And then your only true answers are going to be the 0 and the 180. So in general, whenever you have a trig function, a trig equation that has tan, secant, cotan, or cosecant in it, just double check to make sure your answers don't make any of those undefined. So that's it for quadratic and multifunction trigonometric equations. Again, the key here, just pretend you're dealing with x's and y's and do what you have to do to at least get the trig function to equal a number, and then take it from there. Until next time, this is Mr. Sutton signing off.